All right, here are solutions to the second written problem for Math 243, Spring 2020. The idea in this problem is you are given a bunch of data. Apparently there's some story here, books read by college-age females, whatever, it doesn't matter. Given a bunch of data, and what you want to do first is to sketch a box plot of the data. So for that, you'll want to use your calculator. Sketching a plot in this class is a three-step process. So your first step is to enter your data into a list. So you hit stat and then go into the edit menu to get into your lists here. And let's see, I might already have these in here. 0, 0, 1. I think I already typed these into L1. Guess I should double check while I go through. Looks good. 8, 10, 16, 20. Cool. Save myself a step. So I put my data into L1. You can put whatever you want. That's your first step. Your second step is to tell your calculator that you want a box plot to program your stat plot. So you hit second and then y equals to get into stat plots. Make sure the second and the third type are off. Go into the first type here and make sure it's on, and then select the box plot. So the box plot in this class is always this fourth type here. So that's the one I want. I want to create a box plot from L1. That's where I put my data into the first list. So I'll tell it that. Frequency list is something I always ignore, and then I have an option to choose whichever symbol I think is the prettiest for my outliers. It doesn't matter what you pick whatever makes you happy. And then at this point, you can either program the window or you can do zoom and then stat. If you're going to do zoom stat, make sure your cursor is blinking like a normal cursor, and then hit the zoom button, and then either scroll down to the 9th thing listed or just hit the number 9. Rather than do zoom stat, I'm going to program my window. I'm going to say it looks like my observation should go from 0 to, I don't know, about 50 or so. So maybe my x minimum is 0, x maximum 60, sure, that'll work. X scale, count up by 10's great. And the y's I never have to worry about when I'm making a box plot. So either zoom stat, it'll take you straight to your plot, or window, change a couple numbers, and then hit graph, and you should get your box plot. And here's my box plot, and I want to draw that, and I want to make sure to include a scaled x-axis under my plot. So in the calculator, I started at 0, and I went over to 60. So I don't know, 10, 20, 30, 40, 50, 60, sure. It's probably good enough. And then it's kind of hard to tell because my y-axis gets in the way, but this left whisker should be right here at 0. If you want, you can use the trace function to see that. It says my minimum x value is 0. I'll put the little edge of my whisker right here at 0 to indicate that. And then my first quartile is 3, my median is 5.5, and my third quartile is 13. So I don't know, 3 would be like roughly here. 5.5 would be slightly more than halfway to 10. And then 13 would be a little bit past 10. So maybe something like that. And I can go and kind of connect some points. I got my box, and I have the lower whisker added to my box. And then the upper whisker should go all the way up to 20. So 10, here's 20. There's my upper whisker. Note that my median is closer to my first quartile than it is to my third quartile, and the whisker on the right is longer than the whisker on the left. Those two things are both indicative of a right-skewed distribution. Also indicative of a right-skewed distribution are some outliers to the right. I got one at 35 and one at 49. So 10, 20, 30, here's 35 right here. 49, damn near 50. Something like that. There is my beautiful box plot. Let's see, include a scaled x-axis under your plot. So I suppose I could just leave it this way because it didn't say a labeled scaled axis. But if you want, you could say what we're talking about here, the number of books read in the previous year, something to that effect. Either write it down here or as a heading on your box plot. Sketch box plot of the data. Looks like I've done that. Looks like I have done that. Step 2. Calculate the upper and lower fences. Which observations should be classified as outliers, or which observations? Make sure that your box plot from part 1 shows these observations as outliers. That seems like a good idea. All right, well, if that was number 1, maybe I should label it with a 1. Switch colors and do number 2. Calculate my fences. It's formulas. It'd be awesome if you had those formulas memorized. LF stands for lower fence. UF stands for upper fence. The lower fence is always your first quartile, Q1, minus 1.5 times your interquartile range. And as a reminder, maybe off to the side, the interquartile range is always your third quartile minus your first quartile. My upper fence, instead of starting with Q1, you can start with Q3. It's the upper fence, not the lower fence. And then instead of taking away something from it, you're going to add something to it. And conveniently, that something that you add to it is the same as the something you took away up here, 1.5 times your interquartile range. And so I need all of these values. I can get these values straight out of my box plot using the trace function. I already have them up here. Or I could have, if you wanted to, get those out of one variable statistics on your calculator. Either way is fine. The only advantage of doing one variable statistics is you get your little checksum here. It says that the sum of these observations is 172, which my checksum is telling me that they should be. That's nice. It makes me feel like maybe I didn't mess up when I was typing the data in. At any rate, either from your box plot or from one variable statistics, you can figure out that your interquartile range is 10, and that 10 came from 13 minus 3, my third and first quartiles respectively. And so what you can do is take your first quartile, which, as I said a minute ago, is 3, and add, subtract, come on, there we go, whatever 1.5 times 10 is. Sounds like 15 to me. 3 minus 15, it's negative 12. Don't believe me, use a calculator. Upper fence, let's see, now instead of the first quartile, it's third quartile, so 13. And then I'm going to add this same amount, 1.5 times 10, still 15, 13 plus 15. That's getting me to 28 here. So my lower fence is negative 12, my upper fence is 28. What that tells me is that anything less than negative 12 would be an outlier. There's nothing less than negative 12. 0 is my smallest observation. Okay, but anything greater than 28 would be an outlier. Oh, greater than 28? You mean like 35 and 49? Yeah, exactly. That's why those showed up as outliers in my box plot. Cool. Make sure that your box plot shows these observations as outliers. They did. Calculate the upper and lower fences. Which observation should be classified as outliers? I guess I should say. So 35 and, where did I say it was? 49? 49 are outliers. You don't have to go into this level of detail, but if you want, because they are greater than 28. Or not in between my fences if you want, or something to that effect. That's part 2. Part 3. Part 3 gets to something that I didn't talk about in the video, so I was like, I might as well add that to a written problem. They can figure it out on their own. Part 3, I think in the videos, I didn't explicitly say, what if you had an observation that was exactly 28? Right? I mean, that's my upper fence, but would that be an outlier or not? If it's greater than 28, it's certainly an outlier. If it's less than 28, it's certainly not an outlier. But what if it's exactly 28? Oh, I don't know. Well, why don't we figure it out then? Let's let the calculator figure it out. What if I took this 35 right here and changed it to a 28? So I went back into my data, hit stat, and then went under edit, and found the 35 in the list, the second to last observation here, and just overwrote it, changed it to a 28. And as I wrote in here, that's not going to change my first or third quartile, right? Those are still going to be 13 and 3 respectively. So it won't mess up my interquartile range because it's not changing my quartiles, so it won't change my upper fence or my lower fence. So those still remain the same. But the question is, now this thing, which I'm going to shift over to 28, is my calculator going to depict it as like as an outlier? Or is it going to extend this whisker out to it? Well, let's see. All I have to do is go back to my box plot. You can do that thinking, it's a 3-step process. Step 1, enter the data. Step 2, tell it you want a box plot. Step 3, program the window, all that stuff. But you don't even have to, because you've already done all of that. If you just hit graph, it'll show you the box plot with the new data, because that's still programmed in there to make a box plot out of list 1, which I've now changed. And note that this observation at 35 out here, at 28 out here, the observation that used to be 35 that I changed to a 28 is not an outlier. Right? It just took this whisker and it extended it out to 28. So what I'm saying is if I had an observation of 28 exactly equal to my upper fence, it would not be an outlier. So to be an outlier, you have to be greater than 28, not greater than or equal to 28. When I changed 35 to 28 in my data, the resulting box plot did not show 28 as an outlier. And again, that's because the whisker went out to 28. The whisker indicates the largest observation that's not an outlier. It's telling me 28 was the largest observation in this altered data set that's not an outlier. It's not an outlier. So the resulting box plot did not show 28 as an outlier. So must be greater than upper fence. It's not even English anymore, but maybe you get the point. To be an outlier. Or symmetrically must be strictly less than your lower fence to be an outlier. So there you go. That's the end of this written problem. Maybe yours looked a little bit better than this, but maybe this is the minimum, or at least gives you the ideas of what the answer should end up being. Guess I can throw check marks here because I finished those, and I'll stop this video.